Good morning, good afternoon, or good evening, wherever you might be. So today we're just going to continue um, doing some exercises on equations of planes. And so actually, from the previous video, I said that, well, we stopped at this problem where we're given two planes and we want to determine whether they're parallel, perpendicular, or neither. Um, I just realized that these two planes are perpendicular. Why is that? Because I messed up this part. So when I added those two vectors right here, I made it negative when it's supposed to be positive. And so I just make that positive, so I get plus 1080, right? And 945, so this is negative 1080, so this is 0. And so it's not neither, it's perpendicular. Yeah, that thing's actually perpendicular. Okay. Yeah, they're perpendicular. And let's see if I get it right. Is this only one try? Oh shoot, it's one try. However, let's see. Nice. We got it. Okay. Same thing for our next number, our next item. Again, we want to determine whether our given planes are parallel, perpendicular, perpendicular, or neither, right? Okay, so here's one plane. Let's name it P1 and P2. So one plane has this equation, x minus y minus 6z is 1. And then the other plane, P2, has equation 6x plus 6y. I'm kidding. 6x plus y minus z is 1. Oh, it's 3. Oops. Watch, I'm gonna mess up my answer just because I have the wrong equations. Okay, now we want to determine whether they're parallel. So basically, we're gonna follow the same steps. So we want to check if they are parallel lines. So let's do that. So how do we check again if they are parallel lines? Well, if their normal vectors are equal. See, now I'm writing vectors because I said vectors. Oh wait, did I say lines? Oh my God, I meant planes. Okay, they're parallel planes. So yeah, again, how do we look at that? Let's say this was P1, and then a parallel plane would be like that. That's parallel. P2, uh, forgive my drawing. They're parallel if they have like the same distance here. Basically, they're never intersecting, right? So how do we go about that? Well, actually, I shouldn't have erased it. If you look at their normal vectors, it should be equal. Or not necessarily equal, but it's pretty much the same even with scaling. Because if you scale one of them, then you're just making the vector longer. But otherwise, if they have the same direction, then it means they're parallel. So that's what we want to look at. So for P1, it has normal vector let's say n1, which has components 1, -1, -6, right? P2, where did we get 1, -1, -6? 1, -1, -6. That's it. Now P2 has a normal vector n2. This is 6, 1, -1, done. Right? 6, 1, -1. Now, are they parallel? So let's see. So how we did it previously was we equated them, and one of the vectors is we multiplied by k because we're doing scaling. So let's do that. Is equal to sum k, 6, 1, -1. Now we equate them. So 1 is 6k, so k here is 1/6. Right? -1 equals 1k. What's that? K is, well, k is -1. So it really, these two k's are not equal, so it doesn't scale. We can even try the last one. It's the same thing. And so this will give us a k of, this gives us a k of 6. So they're not equal. So it means it's not parallel. Now let's check if they're perpendicular, right? Check if they're perpendicular. So how do we do that? Well, again, if we have plane P1, and we have another plane here, and let's say they are indeed perpendicular. This is P2. So if you look at their normal vectors, that's perpendicular, and this one perpendicular, then it means their normal vectors are perpendicular. Right? So we're just checking again if n1 and n2 are equal to 0. If they're equal to 0, then it means they're perpendicular, just like the one we did here. And now we're going to do the same thing. So n1 has 1, -1, -6. So we're just writing that out. And then P2 has 6, 1, -1. 6, 1, -1. Is this equal to 0? So we're just going to do dot product like so. Add it. Add it. Is that equal to 0? We have 6 minus 1 minus or plus 6. Oh, so this is not 0. So it means it's not perpendicular. Unless I messed something up again. Which I don't think I did this time. I don't think I did this time. Hopefully not. Okay. Yeah, this is not 0. This is 11. 6 plus 6, 12, minus 1, 11, which is not equal to 0. So it should be neither, right? Should be neither. Yeah. Let's see. Yeah, so it's not parallel, it's not perpendicular. Yeah, so we just find the angle between those two planes. Right? So that means it's neither. See if I can spell neither. Okay. And now what I want to do here is find the angle between them. If it's neither. Because if it's parallel, then there's no angle. If it's perpendicular, it's 90 degrees. But if it's none of them, then it means they intersect. If it's not parallel, it means they intersect. But it's not perpendicular, so they must have an angle. And so how do we do that again? Well, let's say we're given that first plane. Then we're given the other plane. And then this is their angle. That's theta. Let's do theta. Now, how do we manage to get that angle? Well, we can use their normal vectors. So that's the normal vector of the first one. Let's make it a bit bigger. Maybe, ooh, slanted. Okay, imagine that's straight. That's the normal vector of the first one. And then the other one was probably like here maybe. That's, yeah. So that angle is actually equal to this one, right? It's kind of similar to how we did in the first exercise, which was here. And then, yeah, we kind of denoted that as N1 and N2. And then we use that formula to get theta. And so that's exactly what we're going to do here. So let's say this is N1. Then what was this, pink? I can't even tell, colorblind, N2. And then we want to do the dot product. So we want to do N1 dot N2, which should be equal to the length of N1. Keep saying length or magnitude. And then here we want to find theta. Yeah. And we're gonna do it in degrees because it's my homework says to do it in degrees. So I'm gonna do it in degrees. But we can do it in radians, doesn't matter. Okay, now let's try to plug this in. So the dot product, if we just do it like so, so N1 has what components? 1, -1, -6. -1, -6. We're going to do the dot product of that with N2, which has components 6, 1, -1. And then what do we get? We get sum total. So we're just multiplying the components, and we're adding at the same time. This will give us 6 minus 1 plus 6. So we have 11. Because 6 minus 1 is 5 plus 6 is 11. I'm actually just going to write 11 here. So that's your dot product, right? Now, what is N1? What's the absolute value of N1 or the magnitude? That's just a distance formula. So 1 squared, -1 squared, -6 squared. This is 1 plus 1 plus 36, 38. Square root of 38. And then we have N2. So we do the same thing. 6 squared plus 1 squared plus -1 squared, which is again also 38, right? Because 36 plus 2, 38. And now we just plug everything in. So we have 11, which was N1 dot N2 equals the length of one of them times the length of the other one, cosine theta. We can simplify this to be 38 cosine theta. And so theta is just arc cosine of 11 over 38, which is, I don't know, has to have some number, right? Yeah. I just get the arc cosine of that in degrees, and I should be good. Hopefully it's not some random value. 11 over 38. Oh shoot, we got a random value here. Oh, so I have to round it to one decimal place. So I'm gonna say 73.2 degrees. Just gonna include even the exact answer just to be sure. So that's that angle here for theta, as well as for the two vectors here. So yeah, I mean, dot product and cross products are really helpful in determining equations of lines and planes in general. So that's why it's really important in math to, start with the basics, use those as building blocks to do more complicated stuff. Anyway, I'm gonna stop yapping and start writing. So 73.2, and I hope I get it right. Because if I don't, then that's just too bad. Yeah. I mean, it's neither. It says should be neither. I got neither. So, yeah. Okay, let's submit, see what happens. Yeah, I don't see anything wrong. Let's just do it. Yay! We got it. Okay. Now, what's so nerve-wracking is that the homework just gives me like one try to do it for some of the items, because that was multiple choice. So, yeah, don't want to lose points, I guess. Okay, next. Okay, now this one's not multiple choice, so I have more tries than usual. So here we want to find an equation for the plane. And this plane has points. Look at that. Find an equation for the plane consisting of all points uh, that are equidistant or equidistant. Yeah. Equidistant from points -1, -6, 1, 3, and some other point 4, 3, 7. Yeah, very interesting here. So again, to find an equation for the plane, we need a normal vector and we need an initial point. So how do we find that the normal vector and initial point? Well, here we have this information. It has all points that are equidistant. What do we mean by equidistant? Well, equidistant means, I'm gonna Google it. You think I know? Oh. Probably like equal distance. If, oh, there you go. Yeah, equal distance. Yeah, that's something. So they're equidistant. Okay. Now, how do I find all points that are equidistant for the two that are given? Um, yeah, that's interesting. Hmm. Okay. And I'm thinking about it. If you're given 2 points, let's say this is point A, right? Let's say this is A, this is B. Usually when we're trying to form relationships of some sort, because I think here the idea is we want to find some sort of relationship, then we want to name it just to make it easier for us. So let's say I have point A here. I have point B here. Now, how do I find a point that's equidistant? Well, I guess one of them would be like, oh, okay, I have some point C here, and that distance from A to C is the same as C to B. Hmm, that's interesting. So I could do that. So I'm saying this is equal to this. Or I could have some point, let's say D. Oh, this is equal to this, right? So that seems interesting. I guess we can go for a midpoint here. That's what I was thinking. And once we get that midpoint between A and B, A to M is equal to M to B, right? I mean, it should be. And now we can make a vector from A to B, and that will be our normal vector, right? We can do that. Why is that? Because the plane is perpendicular to that vector AB, or to the line segment AB. Yeah, because these points are in the plane. These are in some plane that we're trying to find an equation. And if we use this as our direction vector, oh, that's interesting though. Here's the point. Yeah, I'm thinking. Wait a minute. A, B. Wait, I'm thinking. Um, oh, wait a minute. Did I read the problem correctly? For the plane consisting, what does this plane consist? All points that are equidistant from A and B. So let's say this is some A, this is some B. We got some midpoint C in the middle, or we got some D here. We could do that. And then, oh, wait, yeah, I'm thinking about that. Why is our normal vector A to B? Or should it be? Hmm. So we're finding the plane consisting of all points equidistant from two fixed points A and B. That means any point B on the plane satisfies P minus A, which is equal to P minus B. Perpendicular bisector. I wish I knew that. Yeah. So the direction from A to B is perpendicular to the plane. Huh. Apparently, yeah, that is interesting. Um, it's point A and B. Are they in the plane? Oh, so that means, I see what. Okay, I see what's happening here. So let's actually look at this from, well, this perspective. Yeah, I read the question wrong. So what it's saying is, so when we want an equation of a plane, we need a point on the plane, and we need a normal vector, right? So if we're given some plane, we need some point, and we need some normal vector that's perpendicular. Here in this scenario, so I'm actually just gonna sketch real quick. Sketch scenario, just so that it's easier to look at. Well, here we're given some plane that we don't know. Let's say we're given this plane, right? And this plane has A and no, this plane consists of all points that are equally distant from points A, B, right? So what does that mean? A could be like here, and then B could be like here. And so we have this line going on. We can connect those two. And they don't have to be, I mean, yeah, they could be straight like this. Could be straight. So imagine that's straight. Now we want to find the equally distance point, which is like what? Probably here. Let's say this is M, which stands for midpoint. So this is the distance from M to B. So I'm going to say line segment MB is equal to AM or MA, doesn't matter, right? M is our initial point, but we don't know what that is yet. Now I need to find some vector that goes up or down, but that's perpendicular. Well, we can just use our segment AB, right? So our AB vector can actually give us that same thing, right? So, okay, first, let's find our point. Let's find initial point. So actually, instead of M, it's called P naught, which stands for initial point. So our P naught, which has some X naught, Y naught, and Z naught values, is just going to be the components of B added to A divided by 2, because we're trying to find the midpoint. So we're basically adding them and then dividing them, right? So let's quickly do that. Yeah. So we have from a -6, we're gonna add it to 4, we divided by 2. Boom, that's our X. Then we have 1 plus 3 divided by 2. That's our B. I keep saying B, that's our X, that's our Y. Then lastly, we have our 3 and 7 divided by 2. So it's the middle point. So this will give us the point -1. This is 2, 10, 5. -1, 2, and 5, right? Done. Now we have our point. Now we need to find a normal vector. And let's just say that's n. So I'm gonna say my n is just the vector from A to B, right? Because I can go here from A all the way to B, and it will give me a perpendicular line. So what is this gonna give me? 4 minus -6, so that's 10. I'm just taking into account their changes to get the vector 3 minus 1, that's 2. And lastly, 7 minus 3 is 4. Boom, that's it. So that's the normal vector. Now, I'm gonna try something. Could we have done it just using this or this? Either way, could we have done it if our vector was P naught to B? We'll find out actually. What if our vector is from P naught to B? So B, subtracting it to components of P naught, right? So 4 minus -1. 4 minus -1, so that's 5. 3 minus 2, so that's 1. And lastly, 7 minus 5, so that's 2. So funny enough, it is possible. Lola, this vector is the same as this one. You just divide it by 2. Right? 10 divided by 2, 5. 2 divided by 2, 1. 4 divided by 2, 2. So we could have done P naught to B, actually. Right? We could have done it with that. It's the same thing. But let's just do this. And probably, I wouldn't be surprised, we could also have done it with the other one, which was direction is important here. I think we could have done P naught A. Yeah, maybe. Or no. Or was it the other way around? A to P naught, maybe? Yeah, I think it was A to P naught. Because we're going up. So another way was A to P naught. Let me try real quick. So P naught, let's see if it makes sense. -1 minus negatives. So it's 7. Yeah. I don't think that works. I think it was the other way around. Maybe. Maybe. If it was the other way around, so -1? Yeah, it could have been the other way around. Yeah. Let's see this. Now we have 2 minus 1, so that's 1. Then we have 5 minus 3, so that's 2. There is no way. No, that's not equal. 4 divided by 2 is 2. 2 divided by 2 is 1. So it was the other way around. P naught to A. Yeah, so it's really important that they scale correctly. Yeah, so -6 minus -1, so that's -6 plus 1, that's -5. Oh, but here, if you look at it, it's actually now pointing in the opposite direction. 1 minus 2. Yeah, I think that was, yeah. 1 minus 2, which is -1. And lastly, 3 minus 5, which is -2. So here, going to here is just dividing it by -2, right? But I changed direction. So really the best way is just AB. Or P naught to B. I think, yeah, it's the same thing. But the only reason is that the plane is perpendicular to vector AB, or to that line segment. Now, from here, we have our normal vector, we have our point. Now we use formula and plug it in. That's it. So let's see. So we have 10 x minus, this is our point, x minus -1, so it's plus 1, minus, or no, plus 2, y minus 2 plus 4 z minus 5 is equal to 0. So that's it. That's our equation for the plane. Nice and easy. And yeah. Okay, I could simplify, but do I want to? Probably not. Yeah, this should be chill. Okay, let's do this. So I'm gonna plug in the numbers here. 10 times x plus 1 plus 2 times y minus 2 plus, plus 4 times z minus 5 is 0, right? Okay, let me just see if I typed it down. X plus 1, y minus 2, z minus. Okay, and 2, 4. Okay, now let's. Oh, did I get my numbers right? -1, -613, 437. Okay, I'm just making sure. No, 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 no. Nice. Okay. Okay, last one, and then we'll call it a day. Or I'll probably do something later. Yeah, I'll probably do more problems later, but we'll see. Okay, for this one, we want to find an equation of the plane. So another one of these equations of planes. So what do we need? A normal vector n and some initial point. Ooh, look at that. Now we're given points with x-intercept A. Ooh, y-intercept B. So here we're actually given 3 points this time. So it shouldn't change what we're doing. And z-intercept C. So what does that look like? So I'm going to say the first thing we want to do is translate intercepts to points. Because this is a similar problem where we're given 3 points in the plane. So what do I mean by translate? Well, if we have x-intercept A, this means no, not vector, I'm kidding. This means the point which has A, 0, 0. Y-intercept B is the point 0, B, 0. Z-intercept C, which has the point 0, 0, C. That's a 0, not U. Now we can actually name these points, which I'm gonna do. I'm gonna name these points real quick. Let's name them. Let's just do standard PQR. Why not? Could be any, I don't care. So again, we want to find a normal vector. We actually already have our initial point, which is this one, A, 0, 0. A, B, and C are just real numbers. They're constants. Okay, so let's do this. So how do we do that? Well, again, let's say we have B here. This is not drawn to scale, by the way. We have Q, we have R. Those are some points. And then we want to find the normal vector. So it kind of goes up like that. And then this is our plane. So that's how we're going to do that. So I'm going to say we're going to find the vector PQ. And we're going to find the vector PR. So PQ is what? Q. How many times do I go from P to get to Q. So 0 minus A, so we have minus A. B minus 0, so we have B. 0 minus 0, so we have 0. Right? So here we're just looking at their components. And then 0 minus 0 is just 0. All right. 0 minus A is negative A. B minus 0 is just B. Okay. And then let's do, oh, why is our red? Too weird. That's isn't supposed to be like that. Okay, now that's not working. Okay, so this is from B to R. So 0 minus A, so it's minus A. 0 minus 0, so that's 0. C minus 0, so that's C. And there you have it. We have these two things. Now we want to find vector N, which is the cross product of these guys. So let's do our IJK, negative A, B, 0, negative A, 0, C. And then we have something in terms of I, something in terms of J. I keep saying in terms, and then K. So here we're just trying to find that vector. We're using cross product to do that. So, okay, let's cancel out the I. So we have BC here. BC, 0. Next, we're gonna cancel out the J's. So we have negative AC here, and we have 0 here. Next, we have K. Oh, K then cancel out. Okay. 0, negative AB, so that's positive AB. Or BA, doesn't matter. Right? Okay, now we can translate this problem. So this is BCI. This is plus ACJ. And then this is plus ABK. It doesn't see here. And then now we have these vectors. So BC, AC, AB. So these are just numbers, right? So now we have our initial point, A0, 0. We have our normal vector. And now we just use the formula. So again, it's just letters. So BC, X minus our initial point A, minus A, plus AC, Y minus, this is just 0, AB, C minus 0. And there you have it. We have our equation of the plane with 3 points. Yeah. I'm gonna load the video and see if I got it real quick. Yeah. Probably BC X minus A, BC Y, AB Z. Okay, cool. We got it. Yeah, I could simplify, but I don't want to. It's okay. I'm gonna get confused. At least this one's in. Okay. BC times X minus A plus AC Y minus 0. I'm gonna put the 0 just to be sure. Plus AB C minus 0 equals 0. I could simplify it, but I don't want to. Okay, let's submit, see what happens. Yeah, we got it. Okay, that's it for this video. For the next one, I'm going to be doing exercises on both lines and planes, just to make it a little tricky. So yeah, I'll see you guys in the next one. Oh, I recorded to the cloud. Huh. Are you sure you want to stop? Wait, I recorded to the cloud? Okay, cool. Okay, I'll see you guys.